All right. All right, thanks for joining the webinar. I'm going to go ahead and show you the Artec Leo here scanning the truck bed. So handheld, structured light system, no wires, everything is all in one system, and it has an onboard computer. So basically all I'm going to do is click on the bottom. There's a little trigger. Once I do that, you will see a light emitting from the scanner, and then I just got to point on the part, and then I'm just going to go ahead and start scanning. Once I start scanning, it's just going to start recording here. So what the scanner is doing is just tracking geometry and color of the object, and then aligning the scans based off of those. So we're about halfway done. All right. All good. So I'm going to now bring the data over to the computer and we'll process it from there. All right, so we're done scanning. I took a secondary scan that I'll show you here. We have our first scan 1.1, and I did a secondary scan in green. I actually tried to go underneath a little bit more. I thought that when I finished scanning, I missed a little area, so I just did a quick scan for underneath there. So what I want to do here is actually just go into my global registration. I can use geometry for our global registration. We can use geometry and texture, meaning color, for our registration, and then we can use the reference cloud. That's when we add the Artec metrology photogrammetry tools with that. In the recording, when I record it, I will add a couple little pictures that you'll probably see in the bottom now that go over that reference cloud. So let's go ahead and just do geometry. So what this is actually doing here is taking scan 1 of the Leo and the 3,974 frames, and scan 2, which had the 314 frames, and it's using geometry to best fit align those scans together. If we did the geometry and texture, it's actually going to use the color content in respect to align those scans together. And then third of all, if we use the reference points, it's going to use those points as alignment process. Because the part has a pretty good amount of geometry, I'm just going to go ahead and use that tool for this process. Anytime you do use texture in a process, it does take a little bit longer. So, with such a big file, ranging around 4,200 frames, we're just going to go ahead and use geometry. All right, so we're getting close to being done. You'll see that green bar on the bottom. All right. So once that's done, actually we're missing it right here. So let me settings. There's some things here. So I'm just going to use our error number. So what error is basically standard deviation off the best fit. This is saying within each frame, I can go actually double click in here. And these are errors. So typically you don't really need to worry about these numbers. You'll notice that that error number is actually worst case scenario, zero point 0.8. If the file had bad alignment, it would have an exclamation mark here, or it would say failed. So from here, basically we can now go ahead and create our mesh. As is, in this part, we do have a graded, let's say, bed covering. So I'm hoping that all the data comes out really well here. I just did notice that when we were scanning, I grabbed my foot here, but that's no problem. We're going to go ahead and take care of that later. So from here, I'm actually going to go create a mesh. I'm going to actually do our fast fusion. Under fusions, there's actually a few things here. So outline removal, what outline removal does, it removes out little outline data like you'll see here. And this can be from data we collected, maybe on the wire holding the tailgate up. You can clear those out. I like to not clear those out because sometimes it can delete data that is very useful. So I'm actually going to keep that here. I can always delete it later. Under that, you'll see fast fusion, which I'm doing right now. And then we have smooth and sharp fusion. So smooth and sharp fusion are amazing tools within Artec Studio that I haven't seen in anything else, any other scanners. In sharp fusion, when we're creating a mesh, it will highlight those strong defined areas, sharp edges, holes, things like that. Make sure that the points are very tight and clean. But it also has some tools for filling holes, and I could show that to you after this is done. We can tell the software to fill holes by a certain radius. We can set those for really low or really large. We can tell the software to not fill any holes, which typically I go with. And then we can also make it a watertight mesh. Obviously, this part is not a watertight mesh part. You pretty much would want to do that maybe on something like a basketball or a football or something like that where you really don't have any holes. On the smooth fusion, that will actually smooth out data. So I always careful with that one because it can smooth out the data and change it a little. Where this function becomes really good is scanning people. Sometimes people move, so when the data is smoothed out, it can smooth it out pretty quick. And because this is such a large file, it is going to take a minute. So as we go here on the recording, I'll fast forward it before this is published. All right, here's the file. So this is your mesh file. I did notice that I maybe didn't take enough time and I'm missing some of the data deep in those cracks, but for the most part, if you can kind of see, we were able to collect really good data through the bed area. Just kind of going maybe right to left and up and down would give us some better hole fill in there. I noticed that I picked up my shoes in here, so that's no problem. Actually, you can come in here and erase those. One of the cool features that Artec Studio 17 has this really cool object selection. I can highlight this little area. It will find that individual scanned set if it's not connected to everything else as an object, and we can go ahead and just delete that. Oh, so for some reason it's showing that it is, so let me actually deselect that. Let me see if I can pull up this one. Or maybe I highlighted a different area. So let me just make that as an object. Yep. I'll erase it. And I can do that same thing with it. Let's make sure it's there. Cool. Nice. So, really cool feature. I'm going to close this out on this part. I'm going to go ahead and try to process this with the bigger hole fill and see maybe if we can fill these holes. Hope that demonstration of the bed works out great for you. I'm happy to set up another one and scan a bed without the plastic cover. I know this is a little cover part's a little challenging to capture, but you can see here the data is really nice and clean that we captured. I got this nice lockdown here. You can see, let me pull up the other side because I'm going to go ahead and process this data as well. I did a sharp fusion on this little area. Let's go ahead and process that. So I did this one right here. So this is the HD data, and you can see just by the raw data how clean it is. So for processing time, I'm just going to actually come in here and cut a little of this out. My focus is basically just want to kind of show you that section. Actually, I'm going to keep some of this just to kind of process it. So let's go through this process really quick. So I'm going to go ahead and do a global registration, same thing on just this part. One of the things I want to check is on this battery while we're running here. One of the things that Artec lets us do when we are processing the data to optimize the power actually of the software, we can increase the battery as power and not saver. So I think it's on, turn battery on, let me just look while this is processing. Balance, yeah, performance. So maybe help a little bit out with our performance here. We did this there, and let's just do that sharp fusion. Alright, so got the file, rotate it out a little. I'm going to change the color here from pink to maybe like a light blue or something. So can see a little bit better, but you can see how nice those cleats come out. Holes, very sharp. Definitely a big difference between the standard definition scanning and the HD mode. Even got the key mark in there. And if we kind of zoom in, we even got that hex bolt right back there pretty well. So you can see it definitely a big difference. Really nice and clean on the HD mode. One of the cool things too, we can take this normal scan or big scan data. We can also take the sharp fusion, which we did, and we can actually marry them together. So if you want to get some really high definition, we're just going to go ahead and align here, and we can align that HD file right into that standard definition file. So basically all we have to do is take some common points on the part. Software is pretty smart to know that once we click this align markers, it gets it in general area, click align, and then it will actually use the geometry for alignment. So this is one of the big benefits about Artec Studio and the Artec scanners. You can utilize different scanning modes. So if you do need high definition area in one area and general data on another side, you can marry them and you don't have to process the high definition data. Because we have such a large data set, it does take a little time. So I'm going to hit apply. One thing we can do too is I'm going to hide the high definition. I'm going to come in my eraser marker and actually delete that cleat. then we can come in here and actually take that sharp fusion data and put it right on top. So nice clean data on that high definition area, and we can marry these together, basically export them as one file, and we'd basically be good to go in regards to exporting that file out. So if you have any questions, let me know.